Chapter 6 about the operational amplifier. So in chapter 6, we will discuss about the newly introduces the device that is the operational amplifier. The name of operational amplifier looks like kind of in Korean is 증폭기. We'll discuss about what's the meaning of this, the name. So in this chapter 6, we will discuss about what is the operational amplifier. We call this op-amp. And so at first, we will discuss about the simple model of ideal op-amp models. And when electric circuit have the op-amp, what should we do to solve the circuit or analysis the circuit? And we'll introduce any method to analysis the electric circuit when the circuit has the ideal op-amp. The procedure is node equation. We should use node equation. That is the easiest way to analysis the circuit with the op-amp. Actually, op-amp have been used to build a circuit that perform the mathematical operation. I mean, the mathematical operation means the adding, subtracting, and multiplying and division. To perform that operations that we use the op-amp. So based on the op-amp, we make this operation with the analog circuit. So that was a very useful circuit, and the op-amp is very simple. Actually, how to make an op-amp, there will be out of the electric circuit the subject. If maybe we'll learn the electronic circuit later, maybe next year, then we will discuss about the BJT, bipolar junction transistor, or MOSFET. And using the BJT and MOSFET, you can design the operational amplifier. So we will learn about that subject, how to make op-amp. But in the electric circuit theory, we discuss the op-amp only on a kind of a device, the element of the component of the electric circuit, such as the voltage source and current source, or resistor or capacitor in the same way. So we consider op-amp as a kind of element, some have special the characteristic to do some special things in the electric circuit. So in this chapter 6, we will introduce about what is operational amplifier, the op-amp, and what is characteristic of the model of op-amp. When electric circuit have the op-amp, then what should we do to analyze this electric circuit? We'll discuss about these topics here. So this is the general, the very popular the operational amplifier. Number is Ch07-1. This is the general part number of IC, the op-amp. Op-amp has the 5 pins. We call this as inverting input and non-inverting input. We does not say this is a positive input. We call this as a non-inverting input. And we have 1 output. Actually, this op-amp is the amplifier. What is the meaning of amplifier? It maximizes signals. So op-amp can be models here. This is non-inverting input, and in the non-inverting input, and this is output. So this is called VO. It's V inverting, V plus we call it here. Then this can be modeled. This can be modeled in this way. Here we can make a register here. and this is R is infinity, and this is a kind of the voltage source. I mean, this is, there are some dependent voltage source. That is a K and V plus minus V minus. I mean, the voltage difference between here is multiplied, I mean, amplified here, but the K is infinity. There is a general model of op-amp. Because that this is infinity, so there's no current. This current cannot flow here, even though there's some the voltage difference here, because the current I will be R V plus minus V minus. This is infinity, so there will be 0. So we assume that the current going into the input is 0, and that value go up to the infinity way. We'll redo the op-amp again. So this is op-amp here. This inverting input in, and the non-inverting input, and this is the V out. So we can say this is V minus, V plus, this is V output. Then this can be model, redraw here as V minus, V plus in here. Then this can be model, this is R in, and this again can be model is a dependent source here in this way here, and some register, and this is VO. So this is R out, and this is voltages. It's A, that is V plus minus V minus. So this is op-amp. The equivalent model of op-amp is looks like here. So I mean, V in, actually the V in, the V in is minus plus V plus minus V minus. That value is an input over here. That value is multiplied here. Generally, in op-amp, in the ideal op-amp, R in is infinite value, and gain is infinite value, and R out is 0. That is an ideal op-amp, the parameter. What's the meaning of that? R in is infinity. What's the meaning of that? That means even though this current, there's some current, I is R in and V plus minus V minus. Because this is infinity, their value is 0. That means the current into the input, you say this is the inverting pins, we call this is I minus, and this current I plus, and I minus should 0, and I plus should be 0 in the ideal op-amp. And what's the meaning of the current is 0? What's the meaning of that? I mean, because this current is 0, so that will be the voltage difference is always 0. Why? This is infinite values. If there are some values, That means Vout will be infinite. If we want to not make Vout is not infinite, finite values, we want to get some values of, for example, 5, 10, 3, 1.1, minus 2, whatever it is, to get some values. Because A is infinity, that value should be the 0. So V minus and V plus, the difference is 0 in the viewpoint of the op-amp. We'll discuss about here later. Anyway, this is a op-amp. But there are two another pins here, V plus and V minus. And that is written here. This is V. This is actually not signal pins. This is a supply pins. Plus and V supply minus. I mean, this op-amp has some functions. I mean, the amplifier, the input signal to the output here. To do that, they have some energy, and because they need some source. So in real op-amp amplifier and op-amp, they need some supply to working these functions. So they need this. I mean, generally, this amplifier need the supply voltage here. So this is a general diagram, real model of op-amp. I mean, there are two inputs, one in inverting inputs and non-inverting inputs. This voltage difference amplified to the output node here. And to working here, I mean, they need this op-amp need the power supply. So they have, I mean, this amplifier need the two supply. It's the negative side of the power and positive side of the power. Actually, they should be 0. And we call positive value has, I mean, if there are only the positive power supply, and this is 0, then this is the unipolar, the supply. If there are positive value and negative value, for example, this is plus 15 and minus 15, then this is a bipolar supply. So this is a real electric circuit. So if you make a KCL in this point of here, what's the meaning of here? The supply current I plus and supply current I minus, and input current I1 and I2, and output current I1, because there are 5 pins. So all current of sum, then that value should be 0. Why? Because of KCL. KCL apply all electric circuit, whatever it is, because this is a law that govern the electric circuit. So anyway, the op-amp has 5 pins and 2 power supply pins and 2 inputs and 1 output. And in real model of op-amp, I mean, what is the meaning of the power supply here? That means this op-amp working in the range of this source, positive source, negative source. So if we out to be the high based on the external circuits, but V out will be limited by the source, because this op-amp cannot make more higher, I mean, out of the power supply voltages here. So VO output voltage is larger than the negative power supply voltage and positive power supply voltage. And also the IO is applied by the op-amp. Then the current is limited by the I saturation. I mean, this is a hardware specification. This op-amp, every pin has their ability to supply the current. So this is really limited by that. I mean, the supply current will maybe about 0.x amperes. I mean several hundred milliampere is the general. In general, the saturation, the current, we call that is a saturation current. Of pin. So this is the very real model of op-amp. But when we analyze the electric circuit, if we use the real model, then the problem is very complex. So we cannot solve the problem easily because we have to consider the power source. But in generally, we need only concern about the signal levels. So when you solve the electric circuit, including the op-amp, we use not real model, but simple model of op-amp. What is simple model of op-amp? We consider only the signals, inputs and output. We ignore the power supply pins. So if we use that model, then KCL is not satisfied in simple model amplifier. Why? We ignore the two pins here. I supply plus and I supply minus. So that is not satisfied. So, but the problem is very simple because this is not ignored. And when you use this ideal op-amp, we should remember, we should make these equations because the inner resistor, the input resistor is infinity. So this current and this current in going to the op-amp from the input, I1 should be 0 and I2 should be 0. And this voltage and this voltage is same. Many important. This is very much important. So we have to use that relation. That's all. And at this point, we can apply node equation. But at this point, we cannot apply node voltage method at this point. Why? This circuit does not, and KCL is not satisfied. But here, we can use node voltage here in input side, but the output side, we cannot. Why? We cannot define the discurrent IO. In here, we can define the I in this pin, 0, 0. So we can apply the node equation here. That's the way how to solve the op-amp circuit. But in the output pins here, we cannot know the output current here. So we can apply the KCL in this point, in this node. So I will tell you how to solve the logic circuit when circuit has op-amp. It's very important, very important. Don't forget it. Don't forget this. This is very important. What? I1 is 0, I2 is 0, and V1 and V2 is 0. That is the most important things. Okay? And fortunately, this is all. If you know that, then you don't need to anything more to analyze the circuit. Okay. The example 6 and 3 and 1, we determine the output voltage here. Output voltage is the output voltage of op-amp, VO. This is output voltage. And by the source voltage here. And we read when we redraw this circuit again. Why? I recommend you draw the electric circuit as much as possible. That will be very helpful to understand the circuit for you. And this is op-amp here and input here, and the inverting input is connected by output directly, and the non-inverting input has a resistor and the voltage source, then directly connected to the ground, and output has some load resistor and that is connected to the ground here. That value is for supply voltage VS. This is a supply resistor RS. Okay. and we need to know the VO. That is a problem. So to do that, we should make things like that. I like to use the I minus here and I plus. I decided the name over here. Actually, in our textbook, we use I1 and I2. The notation is I1 and I2, but it will be a little bit confused with the other circuit. So in here, I decided it's I plus. The current in going into the non-inverting the pins, and this is I minus, and this voltage, this node voltage we define V plus, and this node voltage V minus. Then we should remember when we have the op-amp, that is I minus. I minus is always 0, and I plus always 0, and V plus and V minus is equal. At first, you should write this equation first. And what's the meaning of that? I plus is 0. That means I plus current flowing this way. So this current is 0 ampere. So what is the V plus? V plus is, actually we can read over here, this is Vs, and this voltage drop is because current addition in here, so this is a I plus, so the voltage Rs multiply I plus is a voltage drop here. So V plus is Vs minus Rs I plus, but I plus is 0. Why? This is the input of the op-amp. So that means V plus will be the same with the Vs. Oh, we have this relationship. Because of that, Vs will be same with the V minus. That means that voltage is Vs. Then that is connected to the VO. So what's the meaning of that? VO is the same with Vs. That's a way how to solve the op-amp, the electric circuit. It's very simple. Okay, then I will summarize how to solve the electric circuit and having the op-amp. The step one, apply I plus is 0, I minus is 0, and V plus and V minus is the same. In this textbook, they don't use 1 and 2 and 1 and 2 notation, but I recommend you to use the plus minus. And you can choose anything, it's your preference. And then, step 2, to make a node equation at the input node of op-amp. The important thing is do not make node equation at the output node of op-amp. Why? The KCL is not satisfied. Why? In real circuit, there are the power pins, but the simple models, we ignore the power pins. So we cannot make a KCL at the node of output node. So that's a way how to solve the problems, how to analyze electric circuit containing the op-amp. Make a node equation. The remaining thing is other thing. You can use other tips to solve the other in the remaining circuit except the op-amp, using the Thevenin's or Norton theorem and whatever it is. So this example 4 and 1. We have exercise to draw the circuit first. By drawing the circuit, that's very helpful to understanding the like the circuit. In this example, we redraw the circuit here. In there are OPM and minus and plus, and this is a register here. This is 30 kilo ohm, and there are one register here. That's a 10 kilo ohm, and there are one source here. There's a VB, and this is connect to the ground here. And this inverting input of op-amp as in this way. There are one register here, it's 10 kilo ohm. There are register here and 30 kilo ohm, and we connect here. This output, and output is connected register 50 kilo ohm, and this connecting to the ground in this way. And there are another voltage source here, and this connecting here ground because this is VA, and this is defined the V out. So problem is that determine the V out in terms of VA and VB. Why the pin is minus and why the pin is plus? You will see that many op-amp circuit, then minus pin will be connected to the output values in this way. Then we define the pin is minus. We later discuss about that. Maybe we will cover in this electric circuit. We will discuss about the control theory. Maybe we'll learn in the next year the control theory. To control the output, we need to make the negative feedback loop. So then minus means the negative feedback loop. So we define this pin is that pins. Anyway, this is not important in the electric circuit. Okay. So what should we do at first to solve the electric circuit having the op-amp? First, we define the define that current is I minus, and that current is I plus, and that voltage is V minus, that voltage is V plus. We define here and write equation. What is that? I minus should be 0, I plus is 0, and V minus and V plus is the same. At first, write this equation at first. Based on here, next step is make a node equation at this node, the input node here, and here. We have two input node here. First, we make a KCL at this node. We define that node. First here, we make a KCL. Then I will write here. This is okay. I'll use it. I will use that is I1. I make it. This is I2. So what is the KCL over here? Plus I1 and I minus is going out here, so minus I minus, and I2 is going out to here, minus I2 is 0. Because I0 is I minus is 0, so I1 equal to I2. And what is I1? What is I1? I1 is current in here, and this node voltage is, how much is it? VA, and this point is V minus. So that is 10 kilo ohm and VA minus V minus. And what is I2? What is I2? I2 is, this is V minus and this is V output. So V minus minus V out, and logic is 10 kilo. So we in here, so 10 kilo VA minus V minus equal to 10 kilo V minus minus VO. So that will be given 3 VA minus 3V minus is V minus minus V out. So VO will be 4 V minus minus 3 VA. Then we need to know we have one equation here, and next we'll make this node equation here based on here. And we define this current is I3 and this current is I4. The node equation here is KCL, you apply this node, plus I3 minus I4 minus I plus is 0. Because I plus is 0, so we can ignore here. So I3 is the same with I4. Then we need to get the I3. What is I3? I3 is current from the here to here. So 10 kilo ohm. 10 kilo ohm. And from here, this point voltage is VB minus that voltage is V plus. And I4, what is I4? I4 is going from here. This is ground. So V plus divided by 30 kilo ohm. So because I3 equal to I4, so 10 kilo VB minus V plus will be same as 30 kilo ohm V plus divided by 3. So 3 VB minus 3 V plus will be V plus. From here, 3 VB is 4 V plus. Therefore, V plus will be VB. Then we know about that. What's that? V minus and V plus is the same because of OPM here. Then we insert the V minus their values. So 3 VB minus 3 VA. That means 3 VB minus VA is V out. So we can get the relationship between the V out of that value and that value. What is that? Basically, this circuit amplifies 3 times of this voltage difference. This voltage difference multiplied by 3, then that is a V out. So it looks like a kind of the operational mathematical operation. So we call that is an operational amplifier. Anyway, we can solve the electric circuit and having the op-amp in this way. You should remember, if circuit has op-amp, then at first you write these equations. Input current is 0 and voltage difference between two input pins is 0. That means that voltage and that voltage is the same. Then write KCL based on two input node and solve the electric circuit in other ways. Then you can get the analysis of the electric circuit in this way. Here we check the KCL here. Can you calculate this current IO in here? Okay, we can do that here. So, what is I2? I2 is here. And I2 is here. Then, I2, a little here. Based on the result, I will use another. I2 was below V minus plus, VO. Then V minus was VB and insert here. So the kilo and 3 VB minus V out. There will be 40 kilo VB minus 30 kilo VO. That is I2. Then what is that values? Because this current is, we define this I5. I5 is 40 kilo and V out, and 40 kilo V out was 30 VB minus 33 VA. Then what is the IO? Actually, IO means, so based on here, the IO, then IO is IO is minus I2 minus I5. So that values and that values, the sum will be IO. But we don't know how to say that current is 0, that current is 0. So if we apply the KCL here, then IO should be 0. But sum of that values and that value is not 0. That means KCL is not applied at this point. Is it real? Yes, you're real. Why? I told you KCL is a very fundamental law in the electric circuit. So KCL should satisfy in any node in the electric circuit. But why this is not satisfied? Because there are two pins is omitted. This is V supply plus, V supply minus. So there's some current here. Including this current, then KCL, that current is supplied by two pins here. So in real model, the KCL is satisfied at any point. But in simple model, because we omit the power supply to the op-amp, then you cannot apply the KCL at the output node. Don't forget it. If you have op-amp circuit, then you should write at this relationship between the pin current and voltage. Next, make a node equation based on input node. And remember, you should not make a KCL at the output, because at output node you cannot use the KCL. Okay. We'll do the second problem here. This is another example of 4-2. And it looks very complicated, but we need to determine the V out in terms of Vs. So also we'll redo the problem at first. I recommend you, because you are not familiar with the lattice circuit, so when you exercise the problems, you draw your lattice circuit by yourself. During the drawing the lattice circuit, you can understand the lattice circuit, and you can think how to approach to solve the circuits. So lattice circuit, in this problem, there's one source here, minus, plus, and they're very complicated shape, but it's not complicated. It looks like, because it looks, there are many register here. Oh, the direction is different. Plus, minus, and this is Vs, and it's R1, R2, R3, R4, and this is OPM here. It's ground, and there are one resistor, and output is connected this way, and this is plus, minus, this is VO, and there one more resistor here, and there ground here, and R6 and R5. So our target is get the V out in terms of the Vs. Okay, actually this is this circuit has OPM, but even though the OPM circuit is very simple, but the other circuit looks very complicated. So in this case, we don't care about this inner circuit, whatever it is. Then before analysis the OPM, we need to simplify the other circuit at first. So I'm trying to make a simplify at this part at first. Redraw this again. That looks like, we define that is let's say this is A and this is B. Redraw this again. This is R1, R2, R3, R4, and Vs, and this is A and B. So we can make this is a Thevenin equivalent circuit. One voltage source, VOC, and one resistor here. You can make it. You don't care about the inner circuit is complexity. So to do that, at first, what should we do? We make open source voltage VOC, but the shape is very complicated. So to get the open circuit, the voltage, we redraw that point here. We can draw the Vs in this way here, and Vs is parallel connected. What one is R1 and one is R3. And R1 is connect R2. And R2 is connect minus. Also, R3 connect with R4 and R4 is connected to the minus. So here, and A is a point of between R1 and R2. R1 and R2. So this is A. And B is between R3 and R4. So this is B. So VOC is here. So VOC is VA minus VB. And what is VA? We define that as a ground. Now VA is a voltage division of these paths. So VA is R1 plus R2 VS. In the same way, VB is R3 plus R4 VS. From here we get the VOC is VA minus VB is R1 plus R2 minus RC plus R4 VS. This is a VOC. Next, we need to know about RT. Now, what is RT? When you make a RT, then this is RT. To make RT, voltage source, independent voltage source can be replaced with the source circuit. So, to get the RT, this circuit can be rewritten again here. R1, R2, R3, R4, and voltage source here. And we want to see RT in this way, then this can be placed short circuit. Then it looks like R1, R2, and short, and R3, R4 is short. This is RT. That means RT is R1 out parallel plus R3 R4 parallel. So we can written R1 plus R2 R1 R2 plus RC plus R4 R3 R4. So that RT is placed here, and VOC is placed here. So then this electric circuit can redraw is OPM here, minus plus ground, and go up. We make one simple VOC and RT and R5 connect this way, and this is R6 ground. This plus minus V out. The problem is replaced in this way here. So the problem will change. But here RT is R1 plus R2 R1 out plus R3 R4 I3, R4. And VOC is R1 plus R2, R2 minus R3 plus R4, R4 VS. Okay, then problem is changing here. So we need to know V out here. So we really draw here first. V out, then R6, R5, LT, VOC. To solve the problem, we make define the, what is that? We have to write here first. This is I minus, this is I plus, the voltage is V plus, this voltage is V minus. I plus is 0, I minus is 0, and V plus equal to V minus. Then here, V plus connected to the ground. What's the meaning of that? V plus is 0. Because of that, V minus is also 0. So this is 0, and I minus is 0. That means the current over here is 0. So what's the value of V defined? There's a V1. Then here we define this is this current is I1. Then I1 going here. So this voltage drop is LT I1. So V1 is VOC minus LT I1. Because I minus is 0, so I1 also 0. So this is 0, so that means V1 is the same with VOC. Then, because this is VOC, then current is I6. Let's see here. I6 is VOC divided by R6. Then, because I1 is how much is it? I1 is 0 because this current is 0. So this is 0. So that means I6 flow in this direction. So this current is I6. So relationship between VO is V1 plus R5 I6. Then V1 is VOC plus R5, and R6 is R6 VOC. So there is 1 plus R5 R6 VOC. So because VOC here, so VO is 1 R5 R6 R1 plus R2 minus R3 R4 R4 VS. So this is a solution of this circuit. This is the way how to solve the op-amp circuit. At first, you make a simplify, and using the characteristic of op-amp, you can make a node equation in this way here. This is another example. We need to solve two more problems. We need to define the V out. The V out is this is the V out. So we'll try to solve the problem here. I will redraw this circuit again. Okay. This circuit is looks like is a ground, and the current is 20 microamps. Very small current, but in generally the IC, in the IC level, the current is microampere, minus, plus, and there are 40 kilo ohm, and this is output here, and plus is connected here, and the current source here, and 60 microampere, and there one resistor here. This is 30 kilo ohm. Then this junction here is 2.75 volts. This is ground. The resistor here is 45 kilo ohm, and resistor here. Okay, here to solve get the VO, define this contains I minus, this contains I plus, and this is a V minus and a V plus. We write here I minus is 0, I minus is 0, and I plus is 0, and V plus equal to V minus. Okay, then we will calculate the V plus at first. How to get the V plus? Because I plus is 0, so 60 microampere followed in this way. So this current is 60 microampere. So voltage drop here. So because this is a reference, so that voltage is, because addition is plus and minus, so that is minus 2.75. So minus 2.75 is equal to the voltage drop over here. How much is it? 30 kilo multiplied by 60 microampere and plus P plus. So that is a 3 multiplied by 3 and 10 course 6 and 3 plus that value, that is 1.8 plus P plus minus 2.75. So P plus is minus 2.75 minus 1.8 will be minus 4.55 volts. So based on this loop, we calculate the V plus is minus 4.55. Then from here, we already know V minus is also minus 4.55 volt. From here, we know that voltage here. So what is, I minus is 0, right? So 20 microampere flow here because this is 0 current. So voltage difference here is, this voltage difference is 40 kilo ohm multiplied by 20 microamps, and this is V0. There will be this node voltage V minus, that is a minus 4.55. So this is 4, 10, 4, 2, 5 is 0.8. So 0.8 plus V out is minus 4.55. So V out is minus 4.55 minus 0.8. That will be minus 5.35. So that is our result. This is very simple. It's not difficult. So we can choose the simple way how to make the variables and use the simplify the method and get the V out in this way. And this is another example. We'll try to get the determine the V out. The V out is V out here. So we wanted to know that values. Okay. This problem we'll try to solve in this here. At first, we make I plus, okay, and this is I minus, and this voltage is V minus, this voltage is V plus. And then right at first, I minus is 0, I plus is 0, V plus equal to V minus. But we already know what is V plus. In this problem, V plus connected to ground, so there will be 0. So there will be the 0. Because that is 0, so we calculate, define that current is I3. Then how much I3? That voltage is, because this is ground, and then plus minus 3.35. So the current here, I3, is this voltage minus 30.35, and this voltage minus V minus in 20 kilo. And because V minus 0, so there will be written 20 kilo minus 30.35. And this current is 0, so I3 go to in this way. So we define this V3, then how much will we see? The voltage drop here is 40Q and I3. So from here, from here, we minus the same read 40 kilo and I3 plus the V3. So V3 is minus 40 kilo and I3 was minus 20 kilo minus 3.35, and V minus is 0, so V3 is minus 6.7. Oh, actually, no. This is not here, so the plus 6.7. V3 is 6.7. Then, because this is a 6.7, we can calculate, we define this current is I5, then I4, then what is I5? I5 is 10 kilo divided by V3. That means 10 kilo, 6.7. And what is I4? Because this is I3 and this is I5, so I4 is I3 minus I5, and I3 is minus 20 kilo, 3.35, I5 is minus 10 kilo, 6.7. So we can calculate minus 20 kilo, 16 and 75. This is I4. Then V0 can calculate based on V3, I4, A kilo. So V3 is A kilo multiplied by I4 plus VO. So VO is V3 minus A kilo I4. And V3 was 6.7 and A kilo and I4 is minus 20 kilo 16.75. Then our result was 6.7 and plus 6.7. That'll be forward. So we can get the V out in this way here. So it's very simple. It looks like complicated, but you got the op-amp, then you define the variable here and write these equations. From here, you can get the variables from the node point here and get step by step until you get the out voltage. So get the V plus and plus, calculate current. Based on this current, we can calculate this voltage. Based on this voltage, you can calculate current. From the current, you can calculate the V out here. So we can get the variables in a step by step. That's a way how to solve the electric circuit having the op-amp.